Now, I'm going to brief a bit about our group project, which covers digital logic. Our group member consists of 5 people that will be presenting their part. Now, for introduction, digital logic serves a crucial role in shaping the design and functionality of electronic systems, whereby the information is represented and manipulated using binary digits, which is in bits. This project focuses on the practical application of Boolean equations, adept utilization of algebraic simplification techniques, and efficient use of Karnaugh maps for optimization, employing a combination of Boolean algebra where 0 equals to false and 1 equals to true, truth tables, and graphical symbols or circuits. We delve into the design and analysis of electronic circuits. Now, for the objective, we wanted to understand the digital logic of fundamentals. The next one is application of graphical symbols. And lastly, we wanted to enhance our problem-solving skills.
For the next part, I will be explaining the Boolean equation and algebraic simplification. As you guys can see, this is the equation that we have chosen for our project. This equation consists of 4 variables, which are A, B, C, and D. Okay, for the first step of the simplification, we need to factorize some of the variables here. As you can see, we can factorize B bar, C bracket, D plus A bar, D bar. Inside the square bracket, we can simplify it by using distributive law from law of Boolean algebra. In distributive law, A plus B will be equal to A plus P and A plus C. After simplification for D plus A bar D bar, we will get D plus A bar as the final answer. For the next step, we need to substitute D plus A bar in the previous equation. Afterwards, we need to expand back this equation and it will become like this. To make it clearer, we will rearrange the equation to identify the variables we can factorize in the next step. After that, we need to factorize A bar C. And for B plus B bar, we know that it will become 1. So we need to substitute 1 for variables B plus B bar. Next, as you can see, we can factorize C from this equation and we need to substitute 1 for variables A plus A bar. After the substitution, inside the square bracket, we have 1 and B bar D, right? So for this case, we will use null law. Based on null law, if 1 plus any variable, it will become 1. So the answer for the variables in the bracket will be 1. After all the simplification, lastly we will get F equal to C as the final equation for our project.
So now we will look on how to complete our truth table. So first of all, we will try to examine the first equation that we have, which is A naught, B, C. A naught here means that 0, B means 1, B means 1, and also C means 1. So it's 0, 1, 1. So if we look at the truth table, we have this at the left table, the second last row. So when we have the equation, we put 1 at the F part. So we will do the same thing for B naught CD. B naught means that it's a 0 and CD means 1. So 0, 1, 1 at the BCD area, which is at the left table, 4 row from the upper one. So when it is there, we will put 1 in the F part, F table here. Same goes at the AC. AC here means that 1 at the A, 1 at C. So 1, 0, 1, 0 at the table, which is located in the right table, third row from the upper side. So you will put 1 at the F table. And then the last equation will be A bar, B bar, C, D naught. So naught means that 0. So 0, 0, 1, 0, which is located at the left table, 3 row from the upper one. So from having the truth table completed, from there we will be able to complete the Karnaugh map. That's all from me.
Now I will present to you the graphical symbol of this equation, which is F equal to A naught BC plus B naught CD plus AC plus A naught B naught C D naught. This is the main graphical symbol of the equation. In this project, we are using 3 logic gates, which is the first one is NOT, the second one is AND gate, the third one is OR gate. To make it simpler and easy to understand, I will show you one by one. So the first one is A naught BC. Since we are using SOP, which is sum of product, we need the A naught to be 0. So in order to make the output of the NOT gate 0, we will need to input 1. Therefore, A is 1, B is 1, and C is 1. Output of A naught BC is false, which is 0. Next is B naught CD. The output of B naught CD is also 0 because we are using the AND gate. In order for the output of the AND gate to be 1 or true, it needs all the input to be true. For example, if all of the input of AND gate is 1, therefore the output of the AND gate will be 1. So here we can see bulbs light up because the output of this is 1, which is A, C, 1 and 1. Last but not least is A naught, B naught, C, D naught. So we can see here, the bulbs does not light up. Let's put all of this into one big graphical symbol. Because we are using sum of product, we will need to add all of these with OR gate. As we all know, OR gate needs at least one of the input to be true in order for the output to be true. Let's put all of the input into 1. So as you can see here, the final output is 1. The main graphical symbol of equation F equal to A naught BC plus B naught CD plus AC plus A naught B naught C D naught. The output of it is 1.
Hi, my name is Noraina Balkis binti Nur Hisham, and I will explain about simplification by using Carnot maths. My equation is F equal to A bar BC or B bar CD or AC or A bar B bar CD bar. Alright. Step 1 is we will start with this one, A bar BC. A bar is 0 and B is 1. So we take row 0, 1. So we will highlight this line and then we will check for the columns. C is 1 but D is unknown. So C is 1, there is 2 possible, and then but D is unknown, so we will take both of them. So the 1 bit will enter in 2 cell. This one and this one. And then B bar CD. B bar is 0 while A is unknown. So B bar is 0. There is 2 rows that contain B as 0, which is 0, 0 and 1, 0. So these 2 both will highlight. And then C and D are 1. So 1, 1 here. So we will highlight this column. So both cell will enter with 1 bit. And then step 3, AC. A is 1 while B is unknown. So we will take 1, 1 and 1, 0 rows. 1, 1 and 1, 0 rows because A is 1 but B is unknown. So we will take both rows as a possible answer. So we will highlight this 2 line. And then C is 1 while C is 1 while D is unknown, so we will take both possible columns to highlight, and then there is 4 cells with 1 bit will be because there is both from columns and rows. And then step 4 is A bar, B bar, C, D bar. A bar is 0, B is B bar is 0. So we will choose 0, 0 row, and then C is 1, while D is 0, D bar is 0. So we'll choose 1, 0 column. So there is only one cell to enter the 1 bit. And then the last step is form a group of K-maps. So the group of K-maps must be large as possible, and it horizontal and vertical at here. So we will form a one group only. So F equal to C, since only C does not change, since only there is only C that does not change a bit value. So because it's still 1 and 1, but while A, B and D is changed in bit value. So F equal to C. So that is the answer for this equation. Alright, thank you. That's all for me. I will pass to the next presenter.
Now I will show you the graphical symbol of the equation after the cannot map. So after the cannot maps, the final equation is F equal to C. So this is the graphical symbol of F equal to C.